In this video, we're going to look at calculating resistance in series and in parallel. For series circuits, the total resistance is equal to the sum of the individual resistances. So we have this equation which tells us how to find the total resistance for resistors connected in series. For parallel, the equation is a little bit more complex. And it states that the inverse of the total resistance is equal to the sum of the inverse of resistance 1 plus the inverse of resistance 2 plus the inverse of resistance 3. In this first example, we're going to calculate the total resistance for two resistors, one of 10 ohms and one of 40 ohms, but we're going to connect them first in a series circuit for part A, and then in a parallel circuit for part B. Let's start with the series circuit. For the series circuit, if we want to calculate the total resistance, we're going to use our rule up above, which states that the total resistance is equal to R1 plus R2. That's 10 ohms plus 40 ohms. And if you add those together, our total resistance is 50 ohms. Okay. Now it gets a little bit more complicated when you're adding these resistors in parallel. And that's because the equation itself up above is a little bit more complex. And it states that 1 over the total resistance is equal to 1 over R1 plus 1 over R2. So 1 over RT is equal to 1 over 10 ohms plus 1 over 40 ohms. To simplify this, we have to add 1 over 10 plus 1 over 40. In order to do so, we need to make them both have the same denominator, find a common denominator. The lowest common denominator between 10 and 40 is 40. So we have 1 over RT, and our common denominator is 40 ohms. So what do we multiply 10 by in order to get 40? We multiply it by 4. Next, what do we multiply 40 by to get 40? We multiply it by the number 1. So when we simplify this, we have 1 over RT is equal to 5 over 40 ohms. But we haven't satisfied the question yet. The question says, what is the total resistance? What we have found is the inverse of the total resistance. So in order to find RT, what we have to do is flip this upside down, and if you flip one side, you have to flip both sides. So we say that RT over 1 is equal to 40 ohms over 5, and RT is therefore equal to 8 ohms. So the total resistance for this parallel circuit is 8 ohms. Okay, what we've done so far is exactly what you've learned to do back in grade 9. And in grade 11, we're going to step it up a little bit more by doing resistors that are in mixed series and in parallel. So if we take a look at this example, we have these three resistors, R2, R3, and R4, that are in parallel with one another. These three resistors are in parallel with one another, while R1 and R5 are in series with one another. If I want to find the total of all of this, what I'm going to do is simplify it by first calculating what the total resistance of just these three parallel resistors is. So let's start. We're going to find the total resistance of R1, R3, and R4, these guys. Just going to shade them in. This is what we're finding, the total resistance of these three parallel resistors. And I'm going to use the rule for parallel resistors, which states that 1 over RT equals 1 over R1. I'll call it R2 rather, because that's what it says right here, plus R3, that's what it says right here, and R4 because that's what it says right there. So 1 over RT is 1 over 75 ohms plus 1 over 50 ohms plus 1 over 30 ohms. In order to simplify this, we need a common denominator, something that is common between 75, 50, and 30, and that number is 150. So let's ask ourselves, what do we multiply 75 by to get 150? And the answer is 2. Next we ask, what do we multiply 50 by to get 150? And the answer is 3. And finally, we ask, what do we multiply 30 by to get 150? And the answer is 5. So if we simplify this, we have 1 over RT is equal to 10 over 150 ohms. To find the total resistance of this block of parallel resistors, we have to flip both sides. So we have RT is equal to 150 over 10. So the total of this block of resistors is 15 ohms if we simplify that. 150 divided by 10 is 15. So we found the total of this block of resistors. So we're going to redraw our diagram. I'm using the magic of technology to be able to trace this and then move it over. I know R1 is 12 ohms and R5 is 18 ohms, and we just calculated the total of that block of 3 parallel resistors, and we said it was equal to 15 ohms. So if I want to find the total of this now simplified series circuit, all I have to do is add up these 3 individual resistors. So RT is equal to 12 ohms plus 15 ohms plus 18 ohms. Just move this into a clearer spot, not to get it confused with anything else. And if we add those all up, we end up with a total resistance of 45 ohms. So this mixed series and parallel circuit has a total resistance of 45 ohms. And we did that by separating it into simple parallel and simple series resistors. Now for homework, make sure you try these practice problems on page 530, as well as these 2 sections of homework questions from pages 527 and 529. Also complete any LMS quizzes corresponding to this section. Thanks and good luck.